Okay, so in this video, we're going to be seeing how to implement a binary search tree in Python. So we're first going to be looking at how to implement a tree node, just like we did in the linked list video. So we're going to be implementing a tree node, and then we'll build from that tree node to create a binary search tree. And we'll implement a bunch of methods that will help us to add and to check if a value, whether it be a number or another value, exists within the binary tree. So let's get started. So the first thing we need to do is to create a class, a tree node class. So let's just call it tree node, and let's give it a constructor. So let's say init, and then it will just take in self and value. And what are the attributes it's going to have? Well, it can have the value that we just passed, that will be equal to value, and self.left, let's set that to none. Let's set also self.right equal to none. So whenever we create a new node, a tree node, it will have a value, and its pointer to the left node and to the right node will be none, unless we give the node a left and a right pointer. So next, we're going to be implementing the binary search tree class. Binary tree, let's just say binary tree. Let's also give this a constructor. Sorry. Let's take self and then root. Unless it's provided, let's just give it none value, and self dot root is going to be equal to root. Right? That's everything we need for now. So now let's try to implement some methods. The first method we're going to be implementing is to add a number to our binary tree. So let's take a look at this example for it right here. So this binary tree has 6 elements. So the root in this case is 10 right here. As you can see, it's 10. And then its left node is 7. Its right node is 14. Now the left node also has 2 child nodes. The one on the left, that's 1, and the one on the right, it's 8. So the one on the left nodes are smaller than the one on the right in all cases, and that's what makes binary search trees very powerful for searching, for example. So when we want to add any element, how can we do this? We're going to be looking at this in Python now. So let's create a method called add, and let's take in self and value. Now let's create a node, right? That will be tree node, and it will take in the value. Now, if self.root is none, if we don't have anything in our tree, then let's set that value to the root, right? Self.root equals node, and then let's just return. If that's not the case, then we have to traverse through the binary search tree and find an appropriate value for it. For that purposes, we need a current node to indicate where we are at any moment. So let's just give a current node value in our list of arguments, and we'll make sure it doesn't interfere later on. So let's say current node equals none in this case, and then if current node is none, then let's set current node equal to self.root. Yeah. So if nothing has been provided as an argument for current node, then we'll set that to self.root, and then we'll traverse through our binary tree. So, well, what can we do? If the value we've been given is less than or equal to current node dot value, then we look to the left, right? By looking to the left, I mean if current node dot left is none, we look to the left, and if that's none, then we should append that value to the left, right? So self.left will be node, and then we just return. If that's not the case, then we can just call the add function again, so it can recursively handle everything for us. Now, when we call the function, let's try and call the function self.add. We give it the value, and then what should be the current node attribute that we give it? It should not be none in this case, right? It should be the current node dot left, because that's where we are right now. So we'll just say, let's update it right here by saying current node equals current node dot left, and let's just give it current node as its value. Great. Now let's say else, meaning if value is greater than, not less than or equal to, but if value is greater than current node dot value, then we look to the right again. If current node dot right is none, then what do we do? Self dot right will be equal to node, and then we just return. But if that's not the case, then what we can do is again call the add function, but this time instead of setting it to the left, we can just set it to the right, right? So we can just say current node equals current node dot right, and then we can just call the add method with value and our current node. Now in this case, this function will work okay, this method will work okay, but the thing is, when our user tries to call this method, I want my user to only provide the value. I don't want my user to try and interfere with the current node, right? So let me try and create another function, another method, where the user can only call the value with the add method by only providing the value, right? So let's say def add, and then let's give it self and value, right? Just like before, we'll create the node equals tree node, and let's give it the value, right? And just like before, if self dot root is none, then self dot root equals node, and then we just return. Else, let this function handle it for us. Yeah, let the previous function handle it for us. So we want to be able to call this function only in this class. So that's what a private function or a private method is for. Now, how do we make a method private in Python? We can just add two underscores here. Let's create a double underscore right here. Now I cannot call this method outside of this class. That makes it private. So by creating this private method, I can call it now. So I can just say self dot add, and now I can give it the value, and as the current node, I can just give it self dot root, because that's the starting point. Yeah, so I can just clear this now. Yeah, I don't need that anymore. What can I clear as well? I don't need this anymore. This is just for intuition purposes, as I wrote it before, just to see how we get to this point. Yeah, and we don't need this anymore as well. Hope everything is clear until now. And here also, we don't want to call the previous function. We want to call this the one with the double underscore. So we can just put that there. We can just put here down here as well. And now this method is complete. So whenever our user wants to call the add method, so we'll call the add method by only providing the value. They cannot interfere with the current node. Okay, great. Now we're going to be looking at a method that checks whether or not a specific number exists inside the binary tree. For example, if this is our binary tree, our user can call in the object and say, does 8 exist, or like does 7 exist, or does 14 exist, and it will return true or false based on if it exists or not. So let's just call our method exists. Okay, exists, and it just takes in self and value. Yeah, so let's try to think how to implement this. Now, if self.root is none, Yeah, if our binary search tree is empty, then let's just return false. Yeah, let's just return false. If the value that we've been given is equal to self.root.value, yeah, in this case, let's just return true. This meaning, this means that the value that the user wants to search for is the value of the root itself. So in this case, let's return it true. Okay, great. Now the next thing we have to do is we have to check is if it's not none, if the self.root is not none, and if the value is not the same as the root's value, then we have to traverse through the binary tree and check whether or not that number actually exists. So in order to do that, just like we did in the add method, we need some sort of current node that keeps track of where we are, right? So just like before, let's add this current node here. Current node, let's make that none as an initial, as a beginning, right? And if current node is none, yeah, let's set current node to self.root. Yeah, so we'll start from self.root and then traverse through the link through the binary tree. Okay, great. So now we have this current node, and what we can do is just check whether or not the value is greater or equal to the current node's value, right? So if the value that we've been given is less than current node dot value, then it must be on the left, right? It might not be directly the left node, but it must be somewhere in the left, right? So if the value is less than the current node dot value, let's check to the left. So how can we do that? If current node dot left is none, meaning if it's not on the left, let's just return false, right? Let's just return false. Else, if current node dot left is not none, but if it's also not the same value as the value that we're looking for, then let's just call the function again. Let's just call exists again and let that handle it for us, right? It's just a recursive implementation, just like we did in the add method. So let's set our current node equal to current node dot left, yeah, and then let's just return what the function returns. So let's just call self dot exists, and let's just give it the value and the current node. Yeah. Okay. Cool. And let's just move on. Let's continue. If now the value is greater than current node dot value, here we checked if it's less than, and now here on else we'll just check if it's greater than, right? So if it's greater than, we again check what's on the right side. So we say if current node dot right, yeah, if it's none, then it's not on the right side. So we just return false. Yeah. So return false. Else, just like we did previously, we set current node equals current node dot right, and we just return self dot exists of value and then current node. Yeah, this is basically the implementation. This is all that we have to do. And just like before, I don't want my user to fiddle around with the current node. I just want the user to provide the value that it's looking for. So let's implement another function called def exists, and this time it will just take in self and value. Yeah, it will not take in the current node. So just like before, let's say if self dot root is none, if self dot root is none, then just return false. Yeah, if self dot root, or we can just say else in this case. Yeah, else, let's just call this function again. Yeah, we want to call this function, and just like before, we want to make it private so that our user cannot interact with this. So let's give it the double underscore, and we just want to return, yeah, self dot double underscore exists. Let me make this a double underscore. And then we can just call in self, and then the current node that we provided should be our first node, which is self dot root. So in this case, we'll just look at this function again, and this function will handle all of the logic for us. So we don't have to worry about this, just like before, and we don't have to worry about it being none as well. And we don't have to worry about this as well, because this is being taken care of in this portion of the code. So I can just clear up some space here, and we can just make this elif so that everything is continuous. And just like before, we want this to be handled by this function right here, which has double underscores. So let's put the double underscores there. Let's put the double underscores there as well. So this is what basically the implementation of a binary search tree in Python looks like. So just to go over it one more time, we created a tree node, which will have a value, a pointer to a left node and a pointer to a right node. And our binary tree itself will have a root. And we implemented two methods, which are called add and exists, which basically the add one just adds a value to a list. It will traverse through the tree, and it will find us a place for that value to be added in, and it will add it there. And this exists method will just basically check the tree to see if that value exists or not. Yeah, so this is basically what the implementation in Python looks like. Okay, so now that we've implemented these methods, let's try to see them in action. Okay, so let's create an instance of our binary tree class. Let's just call it bt equals binary tree, and let's try to create this binary tree right here. So let's first add 10 for it to be our root. Yeah, so binary tree dot add. Let's add 10 first, and then let's just add anything after that. We can add 7, 14, everything. So 7, 14, 1, 8, 20. Let's add all of them, right? bt.add. Let's do 7, for example, and let's just copy paste it this a bunch of times. Okay, so it was 7, and then 20, 14, 1, 8, I guess. 14, 1, 8, and then 5. Okay, so this should create our binary tree, and if we want to check if this number actually exists in our binary tree, we can just call in the exists function and see what the output for that one is, right? So we can just say bt dot exists. We can call in any number that we want. For example, we can say 20. Okay, so let's call in 20 and see the output for this. Okay, so it looks like we got some type of error. Let's see what it is. So it's saying that we have this self here. Oh, we shouldn't have self there. Okay, my bad. We just put self here. Oh, yeah, this should be value, not self. Okay, let's try to run it one more time. It says it's false. So this should be true. So we're doing something wrong in our exists function or in our add function. So let's try to see what the problem is. Okay. Yeah. So here in our add function, we're saying self.right equals node. And our self doesn't have a right attribute. This should be current node, not self. And we did the same thing right here. We say self.left, where it should have been current node.left. And hopefully we don't have any other mistakes, but let's try and run it and see what the output is. Okay, so now it became true. So we can check in if the root exists. Yep, 20 exists. 7, not 17, 7, Yep, it exists. So we can try to check if another number exists. We can say 8 exists. So let's try to put in a number that does not exist, right? We can try to put in 0, for example. It does not exist. 100. Does it exist? No, it does not exist. So looks like our method was working. So it's always a good idea to instantiate the object of the class you created and put some of the methods that we implemented to work, so we can see if they're working or not, if we made a typo or if something is wrong in our program. In our case, it looked like we had a couple of mistakes in our program. We wrote self instead of current node, and we didn't pass the correct argument in one of our functions as well. But yeah, when we tried to run the program, we saw the error messages and we tried to correct them, and that's always a good idea. So yeah, that's it for this video, and see you guys in the next time.